In Lesson 104, we're going to look at some examples of experiments and deciding if we have statistically significant results. So the first one says, a recent study on malaria transmission in Africa looked at factors that might affect attractiveness of people to mosquitoes. In one experiment, 43 volunteers were randomly divided into two groups. 25 drank a liter of iced tea and 18 drank a liter of water. The number of mosquitoes attracted into nets around each volunteer was counted to provide the data in the table. So we see this as an experiment with our control group being the water group, the T being the other group here. So basically, we're going to start to look at the averages of the two groups and decide if there's a statistically significant difference. Iced tea is our first group. The average, if we added up all of these values, is 23.60 mosquitoes. The water average is 19.22 mosquitoes. So the difference in the means of the two groups, we're always going to do mean 1 minus mean 2. So we have 23.60 minus 19.22. That's going to give me a mean difference of 4.38. And now we're going to ask the question, is that a big enough difference to show the significance, or do we think that's a difference that happens by chance? So a simulation was run where the 43 values were re-randomized into two groups 500 times. The mean differences for each re-randomization are shown in the dot plot below. So we have 500 dots here. So we're going to use this simulation to determine if there is a significant difference in the number of mosquitoes that were attracted to the iced tea group versus the water group. So as a reminder, our mean difference was 4.38, okay? If I look at my graph, 4.38 would fall all the way out here. Now we have 500 dots. There's only one dot that's more extreme than my value. So use the simulation to determine if there's a significant difference in the number of mosquitoes that were attracted to iced tea group versus the water group. Okay, so the p-value here for 4.38, the mean difference of 4.38, p is that we had 1 out of 500 dots that were more extreme. So that's a value of just 0.002. So when we're describing this, that's a p-value that's definitely less than 0.05, 5%, which is our cutoff. So we can say that since the p-value is less than 0.05, so there's less than a 5% chance that my 4.38 difference happened by random chance, there is a statistically, I'm going to abbreviate this so I have room, significant difference between the groups. So it looks like the iced tea does make a difference compared to the water in terms of, just write that in S, how many mosquitoes are attracted. Now, just to follow up with something we did earlier in the unit, the next question says, since this is a well-designed experiment, what does that tell you about the relationship between the choice of the two beverages and the number of mosquitoes that are attracted to people? So since we did a well-designed experiment, we can say causation. So we can say drinking iced tea causes more mosquitoes to be attracted to people and we can say compared to drinking water. I kind of wish when I'd written this I put the compared to drinking water first. Compared to drinking water, drinking iced tea causes more mosquitoes to be attracted to people, but it still gets about the gist of that problem. So we're going to look at two more situations. The next one, this one says, researchers in a sleep lab at a college decided to see how a night of less sleep affected the ability of volunteers to answer 50 addition problems in a minute time span. 30 volunteers who reported sleeping approximately 8 hours per night were randomly assigned to two groups. So these are average sleepers. Group 1 slept 7 hours and Group 2 slept normally. So the one group had less sleep, the one group had normal sleep. The results in terms of questions answered out of 50 are given below. So here's the results of Group 1 and Group 2. So the first question says, which is the control group and which is the experimental group? So the control group is Group 2. And for our reason, we can say because they did normal sleep. Okay. In the same way, the experimental group is Group 1. Okay, so they had less sleep. Okay, so less sleep than normal. They were restricted to the 7 hours, which isn't awful. 7 hours is still decent, but it's less than they usually got. So now we're going to find the average of the first group, so x sub 1 bar, and average of the second group, x sub 2 bar. So now I'm not going to get out the calculator. You could do this in list 1. Just make sure when you do your one variable stats, you get rid of the L2. But I can also just add up all these values and divide by how many there are. So if I added these all up, okay, and divided by how many there are, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 in each group. We would get an average of 28.3 for the first group. And for my group 2, there's also 15. So if I found the second average, I would get an average of 32.6. Now it also asks for the difference value between the groups. We always find the difference value by doing the first group minus the second group. So the difference value is 28.3 minus 32.6. So this difference value is negative 6.3. Okay, so that's our difference value. Interpret what this means in the context of the problem. So going back to what we're talking about, that means group 1 difference value, right, or group 1's average number of questions correct was 6.3 below group 2. So we'll write that out. Group 1 answered an average of 6.3 questions less correct. Let's see there. Okay. So before looking at a simulation, do you think this is a statistically significant result? So answers vary. Maybe you think it is, maybe you think it's not. I mean, if I think out of 50 questions, getting an average of 6 wrong, that sounds pretty significant. But as I said, until we look at the data, we're not quite sure. So now, in order to determine if this was a statistically significant difference, the researchers ran a simulation which randomly assigned the 30 values into two groups. So just like that random assignment to two groups, like we did in class with our simulation the other day, calculated the mean of each group and found the difference value. This process was repeated 100 times, and the resulting mean differences are in the histogram. So what is the p-value for the difference value from the experiment? So specifically, we're asking what is the p-value for negative 6.3. Now realize the histogram is a little more difficult to use than dot plot for this calculation because you can see the range of values but not the actual value for each score. So we're going to approximate a p-value. So I'm going to say that this negative 6.3 is around negative 6. We're going to kind of round it. So I'm going to circle these 4 values, okay, because we're going more extreme, so we're going to the left. So the p-value is 4 values out of 100. So that's 0.04. So we have only a 4% chance of getting negative 6.3 or something smaller or more extreme from 0. Based on your previous answer, does sleeping versus not sleeping make a statistically significant difference in the number of addition problems answered correctly in 1 minute? So we can say yes, and we can simply say the p-value is less than 0.05. Okay, so it is a statistically significant difference. Now, this one I want to change. I meant to have a different number here. It says if the difference value had been negative, I want to make this negative 4.0 here. Would this have been a statistically significant difference? Explain your answer. So if instead we had just had negative 4, that's still towards the tail. But if I circle here, okay, that looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so in that case, P would be 14 out of the 100. Okay, so on this one, we would say no, it's not statistically significant because P is greater than 0.05. So that's our cutoff. We're still using 95%. We're just looking at the one side for the 5% versus the two tails with 2.5%. So we're going to look at one more. This is a Delta math question. A high school track coach wanted to test whether giving students an energy drink could affect performance during the 100-meter race. The coach split 18 boys into 2 equal-sized groups. It should say random assignment, doesn't mention it, but we're going to, go with that. Where group 1 was given the energy drink and group 2 was not. The 100-meter race times were recorded during practice and shown in the table below. What inference can be made about the results? So first off, we have our two means. Group 1 had the energy drink, group 2 did not. We have a 12.7 and a 13.4. So I'm going to calculate the mean difference. So that's 12.7 minus 13.4, which is negative 0.7. So in our question, we re-randomized the groups. There's 200 here. This is a little more general than what we were just doing in terms of calculating p-values, and you'll see that from the question. Let me just get a good zoom so we can see it well and see enough. Okay, this should be good. So here's our choices. First off, negative 0.7 on my graph is going to fall right about here. So that's my second line, okay? So does the simulation show many or few cases that are there or more extreme? If I look at this, it looks like that bar has about 4 in it, okay? So that's 4 out of 200, okay, which is less than the 5%. So I'm going to say that it's few cases where a mean difference of negative 0.7 or less occurred when the groups were re-randomized. So it can be inferred that the mean difference observed in the study, we're going to say, was very unlikely due to random assignment, right? So we're pretty sure it's not due to random chance, okay? Because the p-value is less than 0.5. So it's very unlikely that it was due to random assignment. It's probably a statistically significant difference. So it's a little backwards maybe than the way we've thought about it before, where sometimes we say we think it's statistically significant first. So it's unlikely it was due to random assignment. Otherwise, it would have fallen somewhere in the middle of the graph, right? So we do think that it's a statistically significant difference. So if we were in the other case, if we had something like, let's say right here that was more towards the middle, we would say many cases. So it's very possibly due to random assignment, and therefore it's inconclusive. So that's kind of like the two ways it can go. Homework for this is on Delta Math, and there'll be questions similar to this one.